we said the temperature increases as in certain layers of the Earth's atmosphere, but there's two different things. Temperature is the measure of the average energy of particles in motion, and we'll see a diagram of that and give you a more concrete example. And heat is the transfer of thermal energy between objects, okay? Colliding of objects. So if we take a look at pictures of heat transfer, we'll see here where the molecules are more dense, where there's a lot of them. As I said, if you think about a room of basketballs, the odds of a basketball hitting a basketball, if there's 100 basketballs in this tiny room, they're going to collide with each other. And when two objects collide, they transfer heat. Same thing if you rub your hands together, you create friction. So there's a heat transfer. However, up here in the thermosphere, they call it the thermosphere for temperature, they're saying in the thermosphere that the molecules can move really, really fast, but the odds of them actually colliding with each other, transferring heat, colliding, is very small. So we'll say that the temperature is relatively warm, temperature is really high, but heat is low, because there's no friction taking place. There's no excess heat being transferred between the molecules. Again, if you go outside, close your eyes, you're going to feel something while you're out there. You're going to feel the warmth of the sun's rays. That warmth that you feel, okay, we're going to talk about three types of heat transfer. Radiation is one, is the energy transferred by waves. Light travels in waves. Visible light, which we feel, okay, is transferred to us as electromagnetic waves. Examples of radiation, which we feel, putting your hand close to a light bulb, sitting next to a fire in the fall, or any of the above. Okay, you can feel the heat radiating from the fire when you sit next to a fire. You don't have to touch a hot stove to know that it's hot. If you cover your hand over here, you're going to feel the heat radiating. So there's no contact between you and the heat source. It's just given off. It's moving through a medium, through the air. Second form of heat transfer is by contact, conduction. Thermal energy is always transferred from warm to cold areas. If we take a look at an example of this, if you hold a metal poker over a flame, many of you have roasted marshmallows before. If you take a look next time at a metal poker, it typically has a handle that has a rubber end, a wood end, and that's because heat transfers from the source in contact from warm, we know a candle's hot, from warm to cold. And then eventually it'll work its way all the way up, and unless you have that protective, you're going to feel the heat from the fire. So that's conduction. That's direct contact with the heat source. The third type, the one that we care most about on Earth in dealing with weather, is convection, energy transfer by circulation. Convection is a transfer of thermal energy by circulation of movement of a liquid or a gas. Remember we talked about fluid friction. It can be either a liquid or a gas. It doesn't just have to be a liquid. As air is heated, it becomes less dense. Remember we talked about a gallon of air is less dense than a gallon of concrete. Therefore, it's going to rise. A gallon of concrete will sink. As it says here, cool air is denser, so it sinks. So we take a look at these convection cycles, or convection currents, which they're also called. The sun's radiate heat down to the ground. That radiation, remember, it's sent out electromagnetic waves. All it is visible light, comes down, heats up the ground warms up, and we say that warm air is less dense, so it rises. But as it rises in the troposphere, we know in the troposphere that the air gets colder as we go up in altitude. As we get up higher, it's going to start to cool. And then what it's going to do is condense. It's going to get thicker, or just it's going to become heavier, more dense. And more dense objects fall, so it's going to come back down. But as it comes back down, it's going to encounter the ground heating, which is going to warm it back up and send it back up. So we get this convection current. Same thing in boiling water. Okay? Conduction's taking place on the bottom here. The pan's in constant contact with the heat source. Remember we said in contact, conduction takes place. It's going to heat up the water. As the water boils, the warm water rises, then it's going to come out to the side and cool and sink back down. You can do this with a pot of soup. You'll see that it boils, and we can see that this soup, if you make ramen noodles, is going to spin. That spinning action is because because of the convection currents taking place in here. Convection currents are very important to plate tectonics. We have a core that heats up a syrupy mantle. As that core heats up that syrup, if you think of a lava lamp, the warm magma is going to rise to the surface. Once it gets to the crust, oceanic or continental crust, it's going to cool and sink back down, just like a lava lamp. And it's going to make these circles, these convection currents.